Hello guys, you're welcome to this lesson. In this lesson, we're going to discuss one periodic variation, that is ionization energy. Ionization energy. So in our previous lesson, we discussed the radius of an atom and how it varies on a periodic table. Is that okay? We also explained the concept of atomic radius, what accounts for the radius of an atom on a periodic table, that is when you're considering moving from the left to the right hand side on a period of elements, and also from the top to the bottom of a group of elements. Is that okay? In this lesson, we're going to discuss ionization energy. Ionization energy. What is ionization energy? Ionization energy simply is the minimum amount of energy, the minimum amount of energy required to remove 1 mole of an electron, the minimum amount of energy required to remove 1 mole of an electron from the outermost shell or the valence shell of an isolated gaseous species. Is that okay? Please, the species can be an atom or it can be an ion. So I have the definition on the board. The minimum amount of energy required to remove 1 mole of an electron, from where? From the outermost shell of an isolated gaseous species. The species can be an atom or it can be an ion. In simplicity, the energy that we need to just remove an electron from the valence shell or the outermost shell of an atom, that energy that is required is what we call the ionization energy. Is that okay? It has the unit kilojoules per mole. It has the unit kilojoules per mole. Is that okay? So we take an example. Let's take an atom. So there's a nucleus. We have the first shell. Let's say we have 2 electrons here, and then we have another shell. Let's say we have 1 electron here. And I want to remove 1 electron from this atom. The first electron I can remove is from the valence shell. And in the valence shell here, we have only 1 electron. Is that okay? The energy that I will need to remove this 1 electron in the valence shell of this atom is called the ionization energy. Is that okay? Now, one thing also is, if I remove the first electron, it means that I apply a certain energy to remove that first electron. That becomes the first ionization energy. Do you get the point here? Also, after removing the first electron, if I intend to move another electron, it becomes the second ionization energy. So after applying some energy to remove the first electron, and I then apply another energy to remove another electron, that becomes the second ionization energy. If I remove another electron, it becomes the third ionization energy. So for this one, for example, if I remove this electron here, the atom will change to become like this. It will become this way. The energy that was required to remove this electron from this atom so that there will be no electron again in the valence shell, that energy is called the ionization energy. Is that okay? That energy is called the ionization energy. And one thing is that once an electron is removed from the gaseous outermost shell of an atom or an ion, it leads to the formation of a cation or a cation. Is that okay? So in this example, once I remove this electron here, it means that this atom, let's say it's named as atom A, this atom will change into A plus. The positive charge on the A indicates that an electron has been lost or an electron has been removed from A. Is that okay? That energy that we need to remove that electron is what we call the ionization energy. Is that okay? So if I remove the first electron here, it becomes the first ionization energy or the first IE. Is that okay? To give me this, Is that okay? Now, if I take this one and then I remove another electron from this, it will change into this form. They will be left with only one electron. The energy that I need to remove this second electron from this atom is called the second ionization energy, or the second IE. So for ionization energy, we need a certain amount of energy to remove an electron from the valence shell of an isolated gaseous species. The isolation here is that the atom wouldn't be in a bond, or the element wouldn't be in a bond. Is that okay? It will be left alone. And also in its gaseous form, because it is very easy to move an electron from an atom once it exists in the gaseous form. Is that okay? So that is ionization energy. But the question here is that what will influence the energy that is required to remove an electron from the outermost shell of an atom? Because don't forget that these electrons feel some attraction from where the protons in the nucleus. In our previous lesson, I explained the concept nuclear charge, effective nuclear charge. Is that okay? It means that the protons have a certain attraction for all the electrons. So if you want to remove an electron, it simply means that you need to overcome a certain attraction. Is that okay? So there are certain factors that can influence ionization energy. Is that okay? And these factors can be one, these factors can be one. We can talk about atomic radius. We can talk about effective nuclear charge. We can also talk about screening or shielding effect. We can also talk about penetration effect. And then we can also talk about stability of electron configuration. Stability of electron configuration. All these factors can influence the energy that is required to remove an electron from an atom, by starting from the valence shell or the outermost shell of that atom or that ion. Is that okay? That is the basic ideology of ionization energy. So the factors: atomic radius, we can talk about effective nuclear charge, screening or shielding effect, penetration effect, and then stability of electron configuration. Is that okay? Now, another thing is that they can ask you to explain ionization energy using relevant equations. Explain the concept of ionization energy using relevant equations. So we know that in ionization energy, there is a removal of an electron from a species that is starting from its outermost shell. Is that okay? And we need a certain energy to remove that electron. So in an equation, we can just say that, let's take any element. Let's take a certain element, M. Is that okay? This is element M, or atom M, in its gaseous form. Is that okay? So once we remove an electron from M, it changes to M in the gaseous form, but with a charge on it. Then we write plus E minus. Is that okay? We write plus E minus. What is the meaning of this equation? This equation means that we've removed an electron from M. And once an electron from M is removed, it is no more an atom. It becomes an ion. And that ion is a cation. The energy that we require to remove that electron from M, The enthalpy change or the energy required is what we call the ionization energy. Is that okay? It's what we call the ionization energy. And please also don't forget that this equation here can illustrate the first ionization energy because we've removed only one electron that is indicated on the chart, +1. Is that okay? So this is ionization energy, or we can say the first IE. If I then take this one here, the M plus, in its gaseous form, and I remove another electron, it will change to M2 plus, also in the gaseous form. Then you write +2E minus. The E minus indicates the number of electrons that is removed. Over here is one electron, so I just wrote E minus. The E minus represents an electron. Here, indicating that we remove the second electron, so 2E minus. Is that okay? Now the energy required to remove the electron from this ion becomes our second IE, or second ionization energy. Is that okay? If again I want to move an electron from this ion again, that is M2 plus, if there are still available electrons, and I remove an electron again, it changes to M3 plus in its gaseous form, then +3E minus. This time around, the energy required to move the third electron becomes the third ionization energy. Is that okay? So this is a basic idea on ionization energy. It's the minimum amount of energy that is required to remove 1 mole of an electron from the outermost shell of an isolated gaseous species. The species can be an atom or it can be an ion. Don't forget that once an electron is removed from the outermost shell of an atom, it changes. It's as if it has lost an electron. So it changes from the atomic state into the ionic state. And the ionic state is specifically a cation. It becomes a cation. The energy that is required to do this is what we call the ionization energy. And the factors, I've listed them as well. Now, let's discuss how this ionization energy can vary on the periodic table. That is across the period and also moving from the top to the bottom of a group. Is that okay? All right.